Before we move on to page 7, I just wanted to go over one thing on the bottom of page 6. We ended with this on the last video. We talked about how 159 couldn't be broke down because there were no pairs. We talked about bringing the I out because you can't leave a negative under the radical. The one thing I did not talk about is, does everybody realize why I can't cancel these? Very common mistake on the test. The reason I can't is because there's no 3 here. There would have to be a 3 common to everything, and there's only a 3 common to 2 out of the 3 terms. So if it's not common to every term, it's not a GCF, and we can't simplify. So just FYI, that cannot be simplified there. That is your final answers. Okay, let's go ahead and go to page 7. So solve the equation using the quadratic formula. So we have 2 more. So if you wanted to do either one of these before we start practice, that would be a great idea. You learn a lot more from making mistakes on your own. I'm going to go ahead and get started. So this first one, what do you notice? No x, right? So this is the same thing as 5x squared plus 0x minus 2 equals 0. So it is 0, but it was missing a term, so I write it in. That way it's really easy for me to see this is A, B, and C. Otherwise, I see students call this A and B, and then they call C 0. It's the x term that's missing, so that means B is 0, not C. So A is 5, B is 0, C is negative 2. So we're ready for the quadratic formula, so let's go ahead and write it. We're getting up towards 7. Should almost have it memorized. Opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. So when we plug and chug, get up here a little bit so we have a little more room this time. We get x equals opposite of b. Well, opposite of b is 0 because 0 doesn't have an opposite. Plus or minus b squared, that's going to be 0 again, minus 4 times a, which is 5, times c, which is negative 2. And I'm sorry about my hands. I forgot to apologize earlier. I had a fight with a bougainvillea yesterday, and it won. Not me. 2 times 5 is 10. Okay, so we have 0 squared minus 4 times a, which is 5, times c, which is negative 2, all over 2a. So now we're ready to simplify. So 0 plus or minus some square root over 10. Now we go to our calculator, and this is called the discriminant we're going to learn. So we're calculating the discriminant. So 0 minus 4 times 5 times negative 2. And that would be 40. So hopefully you recognize that 40 is not simplified. It is 8 and 5, and 8 is 3 2s. So it's 3 2s and a 5. I'll do it out here just so you can see what I just did in my head. So 5 and 8, 5's prime, 2 and 4, 2's prime, and 2 2s. So it's 3 2s and a 5. So x equals, so do we need that 0 there? Is 0 plus something or 0 minus something 2 different answers? No, 0 is not going to affect it, so we can just go straight to plus or minus, because when you add 0 to something, you get the same answer. When you subtract 0 by something, you get the same answer. So we can just drop that 0 off. So 40 is 3 2s and a 5. And then over 10. So 2 of those 2's can come out as a single 2 because we're looking for pairs since it's a square root. So that's going to turn into x equals plus or minus 2 radical 10 over 10. So now we just have 2 terms to look for a GCF. Is there one? Yep, 2 goes into both of those. So we can divide both by 2. And we get plus or minus radical 10 over 5. So we can't divide anything with inside, but we can certainly divide the outer numbers. So it turns out to be 1 radical 10, which is just radical 10 over 5. And so that leaves my 2 solutions as radical 10 over 5 and negative radical 10 over 5. So those are my 2 solutions. And again, I only had 2 terms, the numerator and the denominator divide by, because there was nothing up here. 2 was common. So it's like simplifying 2 tenths into 1/5. And then the radical 10 just stayed the same. Okay, let's do this last one and then we'll move on to some word problems. I'll try to keep the answer in there in case you haven't copied it yet. Okay, so this one, not set equal to 0. And since we're not factoring, we don't really care if this is negative, but if you feel more comfortable bringing those over, I do personally, because your answer kind of looks weird when the leading coefficient's negative. So I'm going to add x squared, and then add 5x, add 5x. So now my left side is 0 instead of my right side. So 0 equals, so we did the opposite, both of those canceled. And now let's put this in the proper order. X squared terms first, 5x is second, and they both turned positive because we brought them across the equal sign, and then 21 was already positive. And putting them in the correct order is really important because if you don't, you're going to get your A, B, and C all mixed up. So what is A, by the way? What number's here? 1, right? So A is 1. Don't write 0. If it was 0, there wouldn't be an x squared there. So A is 1, B is 5, C is 21. And let's write our quadratic formula. Opposite of B plus or minus square root of B squared minus 4AC all over 2A. So x equals, opposite of B would be negative 5 plus or minus square root of B squared. 5 times 5 is 25 minus 4 times A, which is 1, times C, which is 21. All over 2 times A, which would be 2 times 1. So get it ready for the calculator. Negative 5 plus or minus that empty square root, and then it's all going to be over 2. Calculator time. Remember, you always do this in the calculator. Even if you can do it in your head, do it in the calculator. Students make sign errors because if there's a negative and a negative, it's going to be plus and so on. So just always do it. It doesn't matter how easy or hard it is. So 25 minus 4 times 1 times 21 is negative 59. This one is most like the test. The test does have an imaginary answer, if I remember right. The only difference is this can be broke down. It's like negative 20 on the test. So not only do you have to take the I out, you have to break down the radical. Here, 59's prime Nothing goes into 59, so yes, we still take the I out, but we leave 59 under the radical like we did on that problem 2 problems ago. So this simplifies to -5 plus or minus I radical 59. And again, we can't break down the 59 because it's prime, which means it has no pairs, and 2. I look for anything common. Nothing's common in the 3 outside numbers besides 1. So we're ready to write our 2 solutions. So -5 plus I radical 59 over 2, and -5 minus I radical 59 over 2. So the only sign that changes is that middle one. The first time it's plus, the second time it's minus, everything else is the same. So that is the one that we should highlight for the test. Most like the test, except the test has one step harder. It's like a 20, which you have to break down into 2, 2, 5, which is 2 radical 5. So it'd be 2I radical 5. But it's otherwise the same. Okay, let's see if we can tackle one of these word problems, and then we'll have to do the second one on the next video. So a ladder is resting against a wall. The minute I see a ladder problem, boom, my mind goes to, oh, well, there's a right angle right there. So this is Pythagorean Theorem. So they always, very, very common is a ladder problem. So when you see ladders, that should be your first thought. The top of the ladder touches the wall at a height of 18 feet. So right here, this is 18 feet. Find the length of the ladder. So we're trying to find this. If the length is 6 feet more than twice its distance from the wall. So here's the distance from the wall. So we have to decide what X is. And I taught this to my 09 students, so those of you that were in my 09 class probably remember this. Whatever follows than is always your X, because there has to be an X in the problem, just an X. Not an X plus 5, just an X. So what follows than is distance from the wall. So that means this is X. Then we reread the problem to find out what to put for the ladder. The ladder is 6 more than twice that. So 6 more than twice that. So you could write 6 more than twice that, or even better would be 2x plus 6. So you just translate it word for word. You find the word than. Whatever follows than is your X, and that's distance from the wall. Then you reread that sentence to get the ladder. So 6 feet more, that means 6 plus, twice means 2 times, and this we called X. And then I just turned it around to make it look better. So I'm just going to put a line through there so we don't get confused. Round to the nearest tenth of a foot. So that's important. That tells you that it's not going to be factorable, that we have to use a quadratic formula for it. That's your hint. And we're not going to break down the radical. We're just going to type it in the calculator. So you guys remember the Remember the Pythagorean theorem from the last chapter? A squared plus B squared equals C squared. So first we have to find C. So this is our C. And remember how it doesn't matter which ones of these are A and B, so I'll just call this one A and this one B. So let's write our theorem. A squared plus B squared equals C squared. And we can't assume that walls are right angles. That's why I put that box in there. So that's something that can be assumed. We're not climbing up the Leaning Tower of Pisa or anything. So in place of A, we're going to put X. So X squared plus, in place of B, we're going to put 18 squared equals 2x plus 6. All of that is squared. And we're going to run out of time, so I'll just stop right there and we'll pick up from that on the next video.